Hi, everyone. Let's talk about improving the TV user experience. The living room is a great place for content, and with so much more available today than ever before, it's no surprise that 1/3 of US households are watching more than 25 hours of content on TV each week. And our TV platform has seen continued growth and momentum as well. Android TV OS now has over 110 million monthly active devices, available on over 300 partners worldwide, including 7 of the 10 largest smart TV OEMs, many with the delightful Google TV experience. So now, the majority of TVs being activated in the US are with Google TV. Now, these are great numbers and it's incredible engagement, but how can we as developers make sure we're bringing the absolute best experience to our users in the living room? Let's take a look at a couple of great ways, starting with an update about Compose, seeing how app bundles relates to TV, and then some updates and best practices for energy savings and user preferences. In all the great content that we've seen at Android Dev Summit, we've seen how how Compose itself results in simplified code that is easier to maintain with accessibility and responsive design out of the box. And you've heard during the keynote about modern Android development, and Florian is sitting right there, is aligned with the goal of putting Compose first. We're working hard on making Compose to deliver a UI framework that enables developers to build world-class apps. And we're in the early stages of making a sneak preview Android X TV Alpha 2 available later today. While the Leanback API continues to exist as an option for developers building TV apps using views and layouts, we're focusing on a few TV-specific components in Compose, and we hope to have more to share about that real soon. So feel free to visit us in the device lab, also during office hours, so we can just chat one-on-one to understand how this aligns with your UI requirements. Next, app bundles. They're a terrific way of optimizing your apps on Android, and these benefits also come to Android TV OS. For starters, it's just a great way of reducing the size of your app. By omitting resources that aren't needed, apps on average can save up to 20% in size compared to universal APKs. For users, smaller app sizes means there's more space to install apps for storage-constrained devices, which is especially relevant to TV. And for developers like you, this also reduces, of course, the risk of being uninstalled. And of course, downloads are faster as well, right? We've seen an 11% uplift in installs from size savings alone. App bundles also simplify your release cycle because there's no need for doing multi-APK store listings with challenges like version numbering. And then through app signing, your release key is protected through Google's security infrastructure, even letting you reset your upload key if you've lost it or if it's somehow being compromised. And by letting Google Play take care of app signing, your key is seamlessly updated for the best security practices for you. In the coming weeks, we'll be communicating about changes to the app submission policies and timelines for migrating to app bundles. All told, app bundles single-handedly brings a wealth of benefits to you as developers and also to your users. Now let's take a look at some quick wins for power savings for TV apps. On mobile, we have hibernation mode, which is critical for putting apps to sleep and to save battery. In Android 13, we're bringing these optimizations to TV, and for your app, this means that you will be clearing out data and putting restrictions on background executions if your app hasn't been launched by the user in some time. Not only is this great for reducing energy, but we can also save really big on storage as well. Let's take a look at an example. A typical app includes a rather sizable APK, its cache and optimization files, and any user data that it might have stored. So by using app bundles, Google Play can create a tiny stub of just a couple of 100 kilobytes, clearing any cache and avoiding optimization files to free up the majority of app storage. Now notice how the user data is being retained, so users can pick up right where they left off and they don't have to log in or anything after waking your app from hibernation. From Android 12 onward, apps can receive media session pause signals when HDMI informs the TV peripheral that it should enter standby. For instance, because it's no longer the active source or the panel is switching off. For you as an app developer, respecting this signal ensures that the device can enter a low power standby state. And similarly, our new policies around ambient mode are there to make sure that apps don't keep the screen on unnecessarily. Now, of course, it's important to keep the screen on while playing content. Makes sense, right? By registering the flag keep screen on, you prevent the device from going into ambient mode and ultimately switching off when video is playing. But just as important, be sure to let the device enter ambient mode when there's no user-initiated video playback. Clear the flag to prevent your user's screen from burning in and also wasting energy. Android 12 and 13 offers users more flexibility in their preferences as well. And as an app developer, there are a few great opportunities for you. From Android 13 onwards, the platform supports hardware switches for camera and microphone, allowing users to completely switch them off. Be sure that your app can adapt to your user toggling these switches in runtime. Audio descriptions are dedicated audio tracks for the visually impaired that describe important bits of what's happening on the screen. A new system-wide accessibility preference in Android 13 allows users to enable audio descriptions across apps. And your app can query this new API in Accessibility Manager to comply with the user's preference for enabling this feature. Improved APIs in the Audio Manager allow your app to anticipate audio routes and capabilities from Android 13 onwards. By using this new interface to query your direct playback support, you're able to understand more precisely which playback mode is supported on the currently active audio route. Also in Android 13, users can use different keyboard layouts. Now, if you're a gamer like me, you might be looking at this WASD keys and wondering, how can I support them on a non-QWERTY keyboard layout? In some countries, it might be AZERTY or AZERTS. And as a game developer, you can now use the new Keyboard Layouts API to map keys and reference them through their physical location. Then let's not forget that users on Android control their devices in many different ways. One such way is through voice commands, like saying things like, "OK, G, fast forward 10 seconds," or "Hey, G, turn on subtitles." There's one thing I cannot stress enough. Users are not interacting with your media app just through the buttons on the screen. Metadata is surfaced, and many media playback commands are done through peripherals, second screens, device connections, and as we've seen, the Google Assistant. So your app should interact with these playback commands through Media Session. Media Session is the bridge connecting content playing in your app and all of those interactions. So let me be clear. You have to use Media Session, or your users will have a bad experience in your TV media app. And to help with this, we recently launched Android X Media 3, making it easier than ever to integrate with Media Sessions, especially if you're using XOPlayer for audio or video. So let's take a look at a snippet for building Media Session with the Media 3 APIs. Notice how this API simply constructs a media session from the activity context in an existing instance of XOPlayer. See how easy this is? It's a one-liner. By adding a session callback, we can go further and support additional commands like toggling closed captions or in altering the default behavior of commands that XOPlayer supports natively. With the reference to Media Session, make sure to release it wherever your media player is being released as well. As long as your media session is not released, it will be available for the media controller to connect to it. If you're, for whichever reason, not using XOPlayer in your app, I urge you to look into how your third-party media player offers media session support. Now, to make all of this easier, we've updated our media session validation tools to support Android TV. Media Session Validator is a tool that provides an easy and automated way of testing your media session integration and verifying it on Android TV. And if you've written your tests using the Media Controller Test app, for instance, by writing custom tests or integrating it into your testing pipeline, you can use its new TV integration to validate media playback and avoid any regressions in your existing implementation. Android 13 Beta 4 for TV is available today as both Android TV and Google TV emulators, as well as images for the ADT3 developer device. The release is just around the corner, so be sure to check the release notes to catch up on all the features that didn't fit in today's update. Many of these concepts are not new as Android developers. Android TV OS is an important member of the Android and Play family, and you've seen the hard work that we've done to bring many of the features that you love to TV as well. All right, that's a wrap. Thanks for tuning in, and enjoy the rest of the show here at the Android Dev Summit.